In the previous video, we had learned about Schrodinger's equation hydrogen atom. In this video, we are going to be talking about the important features of quantum mechanical model. So the energy of electrons in atoms is quantized. So the word quantized means that it has a specific or a certain value. So when the electrons are bound by the nucleus in an atom, these electrons have a specific value of energy. The second point, the existence of quantized electronic energy levels is a direct result of the wave-like properties of electrons. And in Schrodinger's wave equation, these wave-like properties, when they are applied, the solutions that are obtained from the wave equation actually are allowed. So they are allowed solutions, and that meant that the the quantized energy levels is because of the wave property of the electron. The third, that is the Heisenberg's uncertainty principle, both the exact position and the exact velocity of an electron in an atom cannot be determined simultaneously. So this meant that we could not, according to Bohr's model, it said that the electrons have a fixed path. Okay, but according to this model, we cannot determine the position and the velocity. So there is a chance, or there is a possibility of finding the electron at that particular position is what is considered here. That is a major difference between the quantum mechanical model of the atom and Bohr. In Bohr, we spoke about orbits. Notice the word we use, orbits. Here we're going to be using the word called as orbitals. I'll be speaking about that a little in detail in the next point. An atomic orbital is the wave function psi for an electron in an atom. So when an electron is described by a wave function, it occupies that particular orbital. So an orbital is basically the space around the nucleus where the possibility of finding the electron is maximum. So there are various atomic orbitals which can be present, and it is a basically it is the ground or the basic thing required for the structure of the atom. So the electron in a particular orbital will have a specific energy, and each orbital can have 2 electrons in it. So we will be learning about the increasing energies of orbitals and the types of orbitals which are present in the coming videos. And the orbital function, wave function, is a characteristic of the orbital it occupies, the particular electron occupies. And all of this information can be obtained from the wave function psi. And quantum mechanics is what makes it possible. So an atomic orbital is the wave function psi for an electron in an atom. So basically, in detail, we will be learning about atomic orbitals, the types of orbitals, electronic configurations in the coming videos. Last point, the probability of finding an electron at a point within an atom is proportional to the square of the orbital wave function. This is supposed to be psi square at that point. So from the value of psi square, we can calculate where the particular electron, or where is the probability, the maximum probability of finding the electron. As I told you, in the quantum mechanical model of the atom, we are not speaking specifically in terms of the position or the area where we can find the electrons. On the contrary, we are talking about the probability, because according to Heisenberg's uncertainty principle, it is impossible, or it is not possible to predict the electron's velocity as well as the position. Okay, so with that, we finish the various features of the quantum mechanical model of the atom. In the next video, we will be learning more about quantum numbers. We had introduced that in the previous video, but the next one, we will be learning about each of these numbers in detail.